Hello guys, today I'm gonna show you a tutorial of how to run an application with Docker, and we're gonna use Postgres as a backend, as a database, Flask and Python for the web server, and React for the front end. Now we're gonna separate the containers, so we're gonna use microservices architecture, let's say. Let's go step by step how to do that. First, what is actually Docker is a way to run your applications inside something called containers. So instead of having an application to run at my machine, we're gonna actually have an image where we can set up the Python version, for example, the dependencies. We can set up the operating system, and this image is gonna spin something we call container, and our application is gonna run inside it. So pretty much the container is the spinning image, and if I'm gonna push this image and run this image in a web server, either on the cloud or in another machine, it's still gonna run the exact same thing, because our application does not run on the actual on our machine. It runs inside the container. Now, a lot of these images have already pre-built, so we can already use them for our application, and this also saves us a lot of time. For example, right now we're gonna use Postgres. If you didn't have the Docker Compose, if you didn't have the Docker image of Postgres, the way you would do this normally is you're gonna have to go somewhere in the Postgres website, download it, and download maybe a UI or anything. Now the image is pre-built with all the dependencies that you need for the Postgres, for instance. Let's see how to download it from the Docker. So if I'm gonna go Postgres, all we have to do is just pick a Postgres version. Let's say we're gonna pick this one. So we're gonna say DB. Our image is gonna be Postgres, and this is the tag. And now we're gonna set some environment variables that are some default variables that we can use, some variables that we can use. So we're gonna override the default environment variables. We can say password root, user Postgres, and database, my database. Now we also have, now what this is gonna do is just gonna start pulling the image. Now for our backend, we're gonna create first a directory which is gonna call backend. We're gonna create a new file which is gonna be web server. Also we're gonna need a Docker file, and we're gonna need also a requirements file which is gonna have all the dependencies. Now for our backend, what we're gonna use is we need the main Python image. So first of all, as far as the images, there are already some images that are built, but we also can build on the images, so use, for instance, Python as a base image and start adding more dependencies depending on our needs. So let's choose a random one. For instance, let's say I want to choose this one. What I'm gonna write in here is I'm gonna go to the Docker file, and I'm gonna say from Python 3.11 bookworm. I'm gonna add also workdir app, which is the default working directory that is gonna whatever we copy from here, it's gonna get saved inside the image when the image, when the container starts. So it's much better to have it like that, because it's gonna be easier for you to control the mounts and know where your files are located. Otherwise, it's just gonna be saved on the home. Now, what we want to do also is we want to copy the requirements file inside the container, inside the image, sorry. After, we want to say run pip install .r requirements. So this is gonna install our requirements. Also, we want to copy the web server file in there. And as a last part, we want the command to actually run the code, start the web server. So we're gonna say python web server .py. That's all for now. Now for the requirements, we're gonna need those libraries that I'm gonna show you right now. These are the libraries. So this is the Flask to set up the Flask web server. This is the SQLAlchemy, which is an object relational mapping library. So that means that we can write, it's a way of writing SQL queries in a more Pythonic way instead of directly running the query. You're gonna see later. And this is the library to interact with the Postgres, and this is the Flask course library, which is required for you to allow, because React runs on different port than Python. So if you haven't set up, React won't be allowed to do API calls. Now these are the main libraries we need. Now the other thing is, we have to go in here and say web server and say build, because we want to build, and we're gonna say backend. So what it's gonna do is gonna go in this folder and find the backend. And also we need to set up the environment variables. Now the environment variables are gonna be needed in order to connect dynamically to the database. I mean, we can set it up as hard-coded in the image, but if you want to, after this, deploy it on, let's say, on Google Cloud or in AWS, you have to use different environment variables. So it's a good practice to set up the environment variables in your image, and after override them when you run them into a containerized technology, for instance AWS, either ECS, either EKS. Now this should match those above, because where we're trying to connect. We're also gonna need the host to connect. Now for the host is gonna be DB, which is the name of the server. So this is the reference when you want to have a communication with the containers and do a host reference. And you also need the port. The default port for Postgres is 5432. Now we're gonna set up a simple Flask application, import Flask. Now this automatically completes because I've already set up Python to my environment in here. Otherwise I wouldn't have autocomplete, even though the code is gonna run inside the container, as we said. So even if it's red at your machine, doesn't matter, because we're gonna run this inside the container, and not at our PC. And now what we want to do is app equals Flask we're gonna also set a basic root, which is gonna be our main root, def main root. It's just gonna return a hello world for now. I don't care. And I'm gonna say that equals main around the web server. we're gonna say debug equal true. The host should be 0. So this is gonna allow our Flask server to listen to all the APIs. And we're gonna run this, let's say, on port 5000. Now, another thing is, in here, we have to map the ports. Because if you don't set up the ports, if you don't map the ports, what is gonna happen is the web server is gonna run inside the container at port 5000, but it's not gonna be able to communicate with the outside world, which is our host. So when I'm gonna go in here and say localhost, you're never gonna be able the browser. So that's a good start. Now, in order to build the images, usually you want to do Docker Compose build. But when you run it for the first time, if you do Docker Compose up, it's because it hasn't built the image, doesn't know what image is it, it's just gonna first try to build the image. Alright, so that means that I made a mistake in the image. Let's see what I did wrong. Let's go back to Postgres. Oh yeah, this is 14, not 4. Let's try again. Okay, it works. Now, another thing related to the Docker and images is, first of all, by default, this runs on the same network. So they're gonna be able to communicate the containers with each other, first. And secondly, is the volumes or bind mounts. So volumes and bind mounts are two ways of copying code from the outside world inside the Docker image. So actually inside the container. So that means that when I start the Docker image, when I spin the Docker image and this start the container, I can use either bind mount or volume. I'm gonna explain the difference right now. That is gonna get some files or some code or whatever, any kind of, or it may be images, whatever, and add it inside the running container. Now, this is a good way, for instance, if you want to mount a specific file that you want to save inside the container. Or this is a good way, for instance, if you want to have persistent data. For instance, if in our database that we have our container, if we don't use either bind mount or volume, that means that we don't have any way to save the data from the container into a volume or into our host. So that means that when we close the container, the Postgres, everything we saved inside in the container, in our database that runs in the container, it's gonna get deleted because we don't save it anywhere. Another thing is that we can check in here. First of all, it seems that this is up and running. So if I'm gonna go in localhost 5000, we see the local host in here, which is gonna be hello world, is that if I'm gonna say hello world, let's say version 5, and hit enter, this is not gonna show up in here. And the reason is because we made this change in the code outside of the container, in our host. So in order to able to see the change in here, there are two ways pretty much. The one way is to rebuild the image and rerun it, but this is, as you can tell, is gonna take a lot of time. Or another way is to add in your application here, add volume as a bind mount. That means that it synchronizes my host from here to what we have right now inside the container in order to be able to see the change. Now, if we want to see what we're currently running, we can say docker ps, which is gonna show me the containers running. So as you can see, we have the two containers running. And after, let's say I want to see what is inside the container that our web server is running, we're gonna say docker exec it, the container ID and bash. So as you can see, we have our files in here. If I'm gonna right now say cat web server, as you can see that this is the initial, that the image from the image we built that came from here. That we copied the initial web server, but we cannot see the change in here. So in order to avoid rebuilding every time, what we're gonna do is just add this thing in here, do a docker compose down, which is gonna stop our containers, and docker compose up. Perfect. As you can see, it changes, and because it's a bind mount, that means that it syncs this folder in the path. So here's the path because here we use the app path because this is our work directory that we set up here. If you remember. So whenever we make a change in here, version whatever, lagged. Okay. Sorry. When I reload it, it's gonna automatically show up in here. So we're good on this part. Now, what we want to do is we want to create a connection with a database. In order to do that, first we have to add all our environment variables and construct our Postgres URL. I already have it in here. Let me show you how to do that. This is the Postgres URL we're gonna need. These are the environment variables, and we're gonna import. So what's happening in here is that, okay, these are not correct, however. So is when we run the Docker image and we spin up the container, these are the environment variables that are gonna be used inside our container. So when we're gonna say os.getEnviron, whatever we have set up in here, it's just gonna go and try to find it. So the user is gonna be Postgres user, the password Postgres password, db mydb, and after we have the port and the host, which are correct. Another thing is, which is one of the last parts that we're gonna need in here, is that, so when this starts, we want first our database to be ready to accept TCP connections. Otherwise, what's gonna happen is, if it doesn't, is that the web server is gonna start. We're gonna start the web server. It's gonna try to connect to the database, but this is gonna fail because the database is not yet ready. So we're gonna fix this right now. All we have to do for that is gonna say depends on db, and we're gonna say condition, db condition healthy, and we're gonna go in here and we're gonna say, first of all, let me make this a little bit smaller. We're gonna go in here and say health check test pg is ready, and we're gonna say dash u, which stands for user Postgres, dash d, which is gonna be mydb. That's all we need to do for now. And the next step is that we have to add our register, let's say our Postgres URL in the Flask app. And also we have to also import here from Flask import SQLAlchemy. And also you have to add you have to initiate a database like here. So right now what we're doing is we're using SQLAlchemy to interact with our application in the database. Now, as a next step, we're just gonna create a model. Let's say we're just gonna have a simple model with just a user and its email or age or something like that. And what we're gonna do is gonna say username equals db.column db.string, let's say 80 characters, comma, unique primary. Actually now I'm gonna add nullable false equals false, and primary key equals true. So this is gonna be a username, and maybe we can add actually name, and after we can have the age, which is gonna be db.column db.integer nullable equals false. And we have to initiate the database, because this is not gonna get created automatically. So we're gonna say with app.app.context db.createAll. All right, let's see. We can, because we can say docker compose down just to stop everything, and docker compose up. Also for the health check, I think, let me see something. Yeah, maybe it's better to add an interval. It's gonna run a couple of every 5 seconds. Now, in order to see this running services, again, docker ps. So as you see, right now we have the Postgres that started 24 seconds ago, but the web server is not yet up. So if I'm gonna click right now, enter in here, it's not gonna work. Let's see. Okay, now it's up. So if we're gonna say docker ps, we can see that our web server is up and it's listening on port 5000. So let's say again, and it works. That's very good. Now what we're gonna do next is we're gonna add a route to interact with the database. So what we're gonna do is gonna create an endpoint that we're gonna name it users. Now the methods we can allow in here as a first place is we can allow methods equals post comma get. Is the camera unstable? And we're gonna say def users. Users. Now Okay, yeah, this if you run it with debug mode on, so that means that it picks all the changes the moment you make them. So you have to be careful on that. So right now, as you see, my service just stopped. So let me start it up again. Also, you can run docker compose appd to run this in the background. So that means it's gonna start spinning up the services, the containers, but it's not gonna show the logs. Give a minute, sorry. So if I'm gonna not yet ready. Okay, yeah, because this is not correct. This won't work at the moment. That's why it doesn't allow me to do that. But I'm still working on it. So I'm gonna say if. Oh, we're gonna need to import from Flask also the request. We're gonna say if request.method equals get that, then what we want to do is we're gonna say users equals user, which is our model, query dot all, and we're gonna say we're gonna create the list of users, and we're gonna say for user in users. Now, as you can see from here, the user has the name and an age. We're gonna create a new user dict, for instance, which is gonna have the name is gonna be the user dot name, and the age is gonna be the user dot age, and we're gonna append this dictionary in our list. And what we're gonna do eventually, we're just gonna return the user list. That's it for the get. Now we're gonna say in here elif request dot method equal post. What we want to do is first I'm gonna try without error handling. What we're gonna say is data equals request.json. So we're gonna get the, let's assume that the HTTP request is gonna be JSON in the body, and we're gonna say the name is gonna be data name, and the age is gonna be data age. Obviously the error handling in here. Maybe we can do get. So the get, if the value is none, it's not gonna break.